I'm Let me close the recording. Hey guys, I'm Gurash. So I'm from the McMaster Mars Rover Team. I'm a software member right there. And so what we do is we're constructing our own Mars rover, and then we have to make everything, the software system, the rover itself, and we bring it to competitions, and we'll work on like various tasks that like an actual rover would do. So that's what we do at McMaster Mars Rover Team. And one of the main important thing we use is something called ROS. And uh, today I want to teach you guys and show you guys about ROS, because I think it's like if you're interested in robotics, it's a super cool thing to learn about. Okay, so before I jump into what ROS is, I want to briefly explain what kind of software ROS is going to be. So ROS is a robot software platform. So what to summarize what a robot software platform would be, like, if you, let's say you have a car like Tesla. It has like so many different sensors. It has camera, it has radar, it has ultrasonic sensors. The picture doesn't show it. It also has its drive system, and then there's like indoor stuff like your GPS, and there's so many different components to, like, let's say something like Tesla. How do you combine all of these components so that into an integrated system? And that's where a robot software platform comes into use. Um, because these different components need to talk to each other. And so that means we also need the communication system set up between these different components. So that's why we need a platform that allows us to make reusable program, handles the communication. So if the radar sensor can talk to the main computer, main system that makes the decision on how to drive the car, so the communication should be handled in this platform. And also we need support for development tools. So these are like tools like, let's say you have your camera data. We want to know if your camera data is working. So we need like some ways to like be able to visualize your data from different sensors, or visualize your data from like different components of your software, and to understand what's happening in like different components of your software. So you can see in the picture on the right, I have like examples of robot software platforms. And the one we use at Mars Rover, as I said before, is ROS. So what is ROS? Brief, like the definition, like a textbook definition, it's going to be ROS is open source meta operating system. So ROS is not exactly like an operating system. If you went through the installation instructions, you might have noticed you're not really installing like an operating system like Linux, Windows, or like Mac OS. You're just installing like a bunch of packages that run on top of your current operating system. And that's what ROS is. And if you see on the picture on the right, you'll notice that you have your operating system at the you have your operating system, and the middle layer is what ROS will handle. So basically, this ROS will handle the integration between your operating system and the robot components. So it's like an operating system for your robot that runs on your current operating system, and it's gonna allow you to do all the operating system features you want, but with your robot. So that's what ROS is. It's like operating system for your robot, it's going to provide all the features we want from a robot software platform. Okay, so there was lots of example of robot software platforms. So why do we choose ROS? One of the most important reasons is ROS community. So ROS is open source, and it has lots of people building open source packages for us. So if I quickly go to this here, here's like a bunch of lists of packages that's available on like ROS. There's like hundreds of pages here. I'm not going to go through all of them. So these are all packages that you can just download and run, and then it will work for that specific functionality. So let's say you have a camera, and then you want to integrate that into your ROS ecosystem. You don't have to program your own application to do that. You can just download a ROS package that will do it for you. So that's why it's super useful, because you can reuse your program. You can upload your package so that other people can use it. And then you don't have to waste your development time on creating new app packages that already exist. It's also proven in use. ROS is currently used in industrial applications, like for industrial robots. It's also being used in research for robotics, especially in like autonomous robotics. It's also multi-domain and multi-platform. So if you want to install instructions, you might have noticed that you can install it on Linux, you can install it on Windows 10. You can also install it on Mac OS, although you won't have all the functionality. So it is multi-platform. You can use it on different variety of operating system, different variety of hardware, and it's also multi-domain in a sense that you can use ROS for um, any kind of robot. If you have like let's say a tiny RC car, or if you have a arm that you want to control, or if you have a Tesla you want to run with your ROS, you could do all of those. It doesn't matter. It's not made for just one specific domain of use. You can use it for any kind of application, and it can scale up and it can scale down depending on your use case. And lastly, it's functionality. I think ROS is very easy, intuitive to use, and it's very powerful if you use it for robotics. And that's something I'm gonna demo throughout this workshop to show you how easy ROS is to use and how powerful it is. Okay, so there's a big picture here about components of ROS. You don't have to focus on everything here. So the main important thing most of the times we spend up is to take note of is the client layer. So this layer, so this is where you have your APIs for your preferred language. So we have ROS CPP, ROS Pi, ROS Lisp, ROS Java. So these are just APIs that you can use with, like, let's say you want to create your application in Python, you want to click create in C++, or any other preferred language that is supported by ROS. They offer you the API for it. And the three highlighted ones right now on the slides is something we're going to go through today. So ROS handles the communication for us. Like I said before, communication is very important. We need different components of our system to communicate to each other, and ROS does it for us. And it uses ROS topics, it uses ROS nodes, and uses messages, which I'll explain in a bit. Another important thing to note is the software development tools. There's stuff listed like RViz or Qt. These are tools where you can visualize your data. So if you have LiDAR data, if you have radar data, if you have camera data, you can visualize this on a GUI, and you can see what's happening real time with your sensor. And this is super helpful when you're debugging your sensors or debugging your systems in robots. It also has a build systems like Kakin, ROSPAC. These are systems that help you build your code into ROS executables, and these are super helpful for if you to set up automated builds and so on. And there's also simulation, and this is the most important thing that I think ROS has is simulation. So most of the time you don't have your final hardware when you're like developing software for, let's say, a robot, or like for our case too, like for our rover, we didn't have our final rover when we were gonna work on our rover. So what we did was we created a simulation of the rover, how it's gonna work, and we created our software system based on the simulation, and we can just integrate that to the actual hardware we have now, and it's just gonna work seamlessly. And that's where simulation is super helpful. And you guys are gonna do a task at the end with simulations. That's super cool. Okay, so I explained some ROS, the definition, what ROS is. So let's jump more into detail, like how ROS works, how you're gonna run it. So the first thing we're gonna talk about is ROS Master. And for this section, I'm gonna also open up my Ubuntu terminal so that you guys I'll show you guys commands and actually show you what's happening with ROS. So I have ROS installed on my WSL. Of course, you don't need WSL. You can use a Linux terminal if you have one. Also, I'm gonna exit this and put it in this so that you can see my screen better. Okay. Okay, so first thing we have is ROS Master. So the ROS Master is just a name server for node-to-node communications. In ROS, you're gonna have multiple nodes doing different things. These nodes don't know each other. What they know is not ROS Master. What they're gonna do is just tell ROS Master, hey, I exist, and then the ROS Master knows that the node exists. And if you want to talk to a different node, you go through the ROS Master and figure out other nodes you want to talk to. So it's similar to a DNS server. Like if you think about if you want to go to google.com, there is going to be a DNS entry somewhere that tells you google.com is at this IP address. And that's how you end up getting the data from google.com is you go through these IP addresses. A similar mechanism for ROS behind the scenes. So to start up the ROS master, simple command, you just do ROS core. And that starts up our ROS master. You can see it says auto starting new master, and it started it at a URI. So ROS master is going to run an IP address and a specific port. Right now, it's just my local host. It's running at that port, and every other node can just get the information from that port about the ROS master. Okay, so we have ROS master. Next up is of course a ROS node. So node is just a small, a processor. So it's just like any executable. It could be like a README camera data. That could be a node, or it could be like a object detection node. That could be a node too. So nodes are how you're building your functionality in the ROS ecosystem. And to run a node, it's the commands on the slide. And if you guys, I also put the commands on the README page of the GitHub. So we have ROS core and we have our ROS run. I'll go back to the slide. So we have ROS run package name, node name. I mentioned about packages before. ROS operates on a package system. So there's going to be packages, and inside packages, you're going to have nodes. So for this, let me open up my terminal. I'm going to run a new node. Note that whenever in ROS, you don't want to close the ROS master. And for that case, I'm going to open a new tab. And my ROS master is still running because my nodes need to know about the ROS master, right? If the ROS master didn't exist, the nodes will fail, and I'll show you what happens. So let's run a sample node. So ROS run package name. I'm going to run this node that already came with ROS when I installed it. I'm going to use a tab for auto completion. And then if I run that, it's going to open up this GUI, and this node has a GUI with it. So this is running. This is our node running using ROS run. I'm going to close it for now. We'll come back to it. So let's go back. Let's close our ROS core. So ROS master, and then try to run the node again. You can see it says failed to connect master. That means our master is not there. So for the nodes to run, we need the master. So next up is ROS launch. You might note that if we use ROS run, if I run ROS run, I'm using up this shell session to run that node, and that would mean I would end up opening more sessions. I would keep on going or running like, let's say our system has like 10 nodes. I would have to use 10 shell sessions to like open up 10 nodes. That doesn't seem like very efficient, and that's where ROS launch comes into play. So what ROS launch does, you have a launch file that allows you to run multiple nodes at once. And I can show you an example when we have with our rover system. So let me quickly go show you one. First, I have to go to the folder. Let's see, launch. And then I think we have lots of launch file here. If I do this one. Okay, so there's a launch file. Launch files are just XML files with configuration. So we have 2 nodes here. That means if you launch this launch file, it's going to run 2 nodes. You can have multiple nodes in a launch file. So this is how usually you end up running ROS programs. You just use the ROS launch command. You'll also end up using this command later. So what happens if I run this launch file? So note that I don't have my ROS core running. You would expect it would complain about it, but the thing about with ROS launch is it starts the ROS Master for you. So that's a useful feature of using ROS Launch. So you don't have to, run your ROS Master in a separate shells session and then do your ROS Launch. That's why most people end up using launch files to run your systems, because it's just simple and you just type in one command and it will start up your whole system. I'm just gonna close that. There was errors because I need to set some stuff up. Yeah, but yeah. So now we had our ROS nodes. So how do these nodes communicate between each other? So that's where messages and topics come into play. The terms are very literal in this in ROS. That's why it's like very easy to understand. So messages nodes are going to send messages between each other, and these messages can be integer, floating point, boolean, and there's going to be complex types, like where you could have nested messages and stuff. And these messages are going to be in a specific topic. So nodes are going to be talking to each other relative to a specific topic. So if I go to this slide, before you can see the image where we have like a topic of image data. So the camera is talking to the object detection node. Let me sorry about that. I want to get the pointer. Okay, so the camera is talking to the object detection node using this topic called image data. So there's also publishers and subscribers, which I'm gonna explain quickly. So publisher and subscriber is very fairly obvious too. Publisher is going to just send out data, and then the subscriber is going to subscribe for data. And these publishers are going to register their information with the ROS Master, and that's how subscribers will know about them. They don't directly talk to each other until they subscribe to a specific topic. Okay, so you have a publisher like a camera. Let's say you have a camera node that takes in camera data from a sensor, and it's going to publish it through a topic called image data. And then you could have a subscriber called object detection, right? You need your camera data to do object detection on it. And it's a fairly simple flow of information. And subscribers are just going to subscribe to the topic they're interested. So another key thing to note is that you can have multiple subscribers for the same topic. So this allows you, because sometimes you're going to have components that use the same sensor data, and you don't want to restrict that to just one topic per one subscriber. So you could have multiple subscribers for the same topic, so that the same information can be used by different nodes to do different actions. And with that, I want to do some more terminal stuff. So let me just clear my screen. Let me start up my ROS Master again with my ROS core command. Okay, so if we go back to my to the README, I have some commands about ROS topics and ROS messages. So before I do anything, let's look at the topics that the current ROS ecosystem has. So to do this, all I have to do is ROS topic list, right? This is going to list me all the topics that my ROS ecosystem has currently. You can see there's two topics. One's ROS out and the other one's ROS out HEG. And I want to know more about these topics. So for that, what I can do is I can type in ROS topic info, and then I can type ROS out. This will tell me more information about a specific topic, and this is telling me some information. And this is telling me that it's of type message, it's a log file, it's a log message, and then it has no publishers and it has one subscriber, right? So that means there's a node that's waiting for data from this topic, but there's no publishers. Okay, so we talked about messages. Let's look up what this message is about. So I can do ROS message info to get more info about a message. So you might have noticed by now, most ROS commands start with ROS. And if you ever forget a command, what you can do is type in ROS and double tab, and it should tell you all the options you have. And these are all the ROS commands. But for now, we don't have to know all of them. So let's do ROS message info to just get more information about this message called ROS graph messages / log. If you see, this is like there's a lot of data inside it. There's some bytes and bytes. There are some strings. So this message has like a different data. So that means this is what would be passed from like one node to another. So one node would be like would set all these data to something, and then it will pass it through a topic to a different node. Okay. So now that we have our ROS message info, and we have our ROS topics, and I talked about publishers, let's create a publisher in the terminal. Okay, so to create a publisher, of course, you can do it in Python, you can do it in C++, but that's going to be more complicated because you have to build your executable and stuff. But you can do it simply in the command line using commands like ROS topic publish. So if I do ROS topic publish, this means I'm setting up a publisher, and then I want to specify the topic I want to use, like this. In this case, I'm just going to use test topic. And then I want to specify the message type. In this case, I want to use the standard messages that comes with ROS. I just want to use a string because it makes it easier to see what's happening. So I want to use a string. So what's the data going to be? I can use a dash and then specify the data, which is going to be hello. Before I do that, well, if I type this now, it's just going to publish it once and then stop. So, but I want to publish it every 2 seconds. So what I can do is set the -r argument. So, and that will publish it every 2 seconds, the data hello in this topic. So it's publishing it right now. You can't see anything because it's just publishing it. I'm going to open up new shell again. Remember we did the ROS topic list command. If our publisher is working correctly, our topic should be here because we're publishing to a specific topic. So you can note that our topic is in here. And if you do the same thing like before, ROS topic info, auto-completed, and tells us it's a string message and it's being published by this node. It has a gibberish name because it's like a command line node. So it doesn't have a named value for it. A normal node will have a named value for it. Okay, so we have our publisher, that's fine. How about a subscriber? We should make a subscriber. And to do that, I'm gonna clear my screen first. We're gonna use this command called ROS topic echo. So what it does is just echoes the information for the data from a topic. So if I do ROS topic echo, and then I need to pass in the topic, remember our name was test topic. If I do this, it's gonna every 2 seconds it's saying I'm getting data called hello, right? That's what's happening. And this is a cool, you can see the command line, but for some people you want to visualize what's happening. Like this is not enough. Like what is happening behind the scenes, and that's where what I talked about software development tools comes into play. ROS offers you to visualize your system using tools like this one, which is the RPD Graph. So let's run this node that comes by default with your ROS graph. It's from the package RPD Graph, and the executable is named the same thing. If I run this, after a few seconds, a window should open up. And this is telling me the current ROS ecosystem, like what's happening right now. So there's 2 nodes, the circle are the nodes, and the arrow is telling us how it's communicating. It's communicating through a topic called test topic. As you can see, the names are gibberish for the nodes because we didn't name them. We don't name them in the command line. So let's do an example where we have named nodes. I can leave this open. I'm gonna open a new shell. I'm gonna run this node that also should come with your default. This node that we ran before too. So it's the turtle sim node, and if we run this, it should open up this again. And if we refresh, this node should show up here, but nothing's happening. No one's talking to that node with any topics or something. But this node is basically a subscriber, and it subscribes to velocity data. And so what we'll do now is run this one. I keep opening up the terminals. So yeah. So if you go back to this package, TurtleSim, it also has another node called Turtle Teleop Key. So what this node does is allows you to, teleoperate this turtle using your keyboard input. And let's try that. So it's just like, let's run that. It's saying use arrow keys to move the turtle. So if I use arrow keys, it's gonna move. And if I go back to my diagram, if I refresh now, you'll note that now the TurtleSim has an input from this topic that's being sent by the teleop turtle. So that means this keyboard input is being transferred as command velocity commands to the TurtleSim node. That's how the turtle is being moved. So what is the turtle1 command velocity? Let's do the ROS topic thing again. As you can see, our other nodes are still there because I didn't close them. But if I do close them like here, and this is the visualizing thing, and let me close this one too. And those nodes are gone. So as I mentioned, we want to know about this topic, the turtle1 command vel. So let's look up more information about it, because right now we don't understand what's happening. So we have our publishers, which is the teleop turtle, which is publishing data to the subscriber, and the message is this geometry messages twist. Twist messages are basically how you send velocity information from one node to another. And let's look up what exactly it is, right? ROS message info. I'm going to look up the message information. And you can see it's just a 3D vector of x, y, z that tells you the linear velocity and the angular velocity. So that's how the turtle knows how to move like straight or turn and move. You set the velocity and it's going to move that specific way. So these are ways we run our publishers and subscribers using our terminal. And for key thing to note is you usually don't end up running your publisher and subscriber from terminal. This is just to test out stuff. So I'll just show you a sample like Python publisher we have in our repo for not our Rover repo. So if I go to my source folder here, yeah, so let's do that. Okay, so this is just a Python program we have that's subscriber. So you can note that it's just Python. We import our ROS by. So this is how you use your ROS API in your like Python, C++, Java. You would just import the specific API library, and then you would just use functions from it. Like in this case, we're just subscribing to this topic called /showdown. And this is how you would usually end up creating your application. You would end up setting you would write like, let's say, Python scripts to run your nodes, or it could be in C++, and then you would just use your API to set up your publisher and subscriber, and then you would have your whole system like built up like this. Of course, there's more than publisher and subscribers, but most of the time you end up using publishers and subscribers, and I think that's a good starting point too. Okay, so back to the slides. We went through a lot here, so it might have been a lot of information at once. So if you do have questions, feel free to put it in the chat. And before, the next thing is the interactive demo. But before we do that, I just want to explain what SLAM is, because you're going to be using this in the next part of the interactive demo. So SLAM is basically a way for the robot to map its environment. Let's say you walk into a room. As humans, we use our eyes to figure out distances between objects. We can like tell the depth, and then we map out our surroundings. That's how we know like our chair is here. If we sit here, there's a chair behind me. There's going to be my table on my left side. We know all of that information. The same thing can be done with a robot, but what you need is the eyes for the robot, and that's where the sensors like camera, laser scan, like laser scan, that means like lidar sensors, which tells you like exact distances between 2 points, because it's going to bounce off a laser and tell you how far a specific object is and stuff like that. And you also have encoders on your motors that will tell you how much you moved. These all this information can be fused into an algorithm called SLAM, and what it will give you is output is a map. So if you see the GIF on the right, you could see the robot is moving around in a simulated world, and as it's moving around, the map is going to be constructed, because this makes sense. It's the same as we do for humans. If we go into a room, we're not going to get the exact layout of the room until we see every part of the room, and that's how SLAM works too. And the robot has to move to every corner to see like hidden spots, and then it will figure out the whole map. And SLAM is like widely used algorithm everywhere. Like I'm pretty sure Tesla uses it to any autonomous robot that has to move around in obstacles or in a surrounding environment probably uses SLAM in some sort of way. That's why I'm excited for you guys to try out the interactive demo in the next part. So yeah, be ready. So I'm just going to pass it to Hashim, who's going to go through the interactive demo. If you have any questions until this part, feel free to type in the chat. I know I went through a lot of theory. You might not understand it, but for the interactive part, Hashim will just tell you what commands to use. And if you understood any bit of the theory, it'll make a bit more sense. But yeah, feel free to ask questions. And Hashim, you want to take over?
Yeah, thanks, Virosh.
Yeah, no problem.
Hey, everybody. So I'm Hashim, and I'm in my second year studying mechatronics engineering at McMaster. And I'm going to be taking over this interactive demo. So I'll start by sharing my screen. And this interactive demo is meant for anybody who followed the instructions on the GitHub, the pre-workshop installation instructions. I'm on Windows 11. It should work exactly the same on any Linux computer as well. You will need a GUI environment. This demo will also take up a lot of your screen space, so I'm going to be managing that on mine, so you can follow me as well. So I'm going to be following all these steps in this interactive demo, so you might want to have this open, and we have a link in the chat as well, which you can open up. So let's start off. So step one, open terminal window. So if you just have a Linux installation, you can just open up a terminal window. I have WSL, and cool thing is in Windows 11, we actually have GUI support. So I can actually run some GUI applications as well. So we opened up our terminal window, and I'm going to go into step two. And this, we need to actually copy this command here. And this, because of the way our launch files are set up, we just have some environment variables. And I'm just going to copy this by selecting this, Control-C, and then over here I can paste this by right-clicking and enter. This pretty much makes it so that instead of every time writing this command, every time we open up a terminal window, it'll automatically type this command, because we put this in our bash RC file. And this just sets like the simulated robot model we're going to use, because there's a couple different options that we can use for this demo. And so as we saw with Virosh's demo, we'll need to be using a couple terminal windows as well. So I'm going to be making this one a bit smaller. I'm going to open up 3 more. So I'll have 4 total. And I'll place them all like this, so that they all take up a quarter of my screen total. So Okay. Okay, so the demo that we're gonna.
Yeah, let's wait to see if people are at this step. Yeah. Yeah. If you guys have had any problems to reach this step, feel free to type it in chat. If you're good, you can just thumbs up or say I'm good.
Okay, if anybody needs some more time, let me know in chat so I can slow down a bit. All right, so our next step is we're going to be running some launch files. And so these launch files are going to be running a couple different nodes to set up our turtle bot. So to actually, since we don't have a physical robot, we're going to be using a program called Gazebo to actually simulate our robot. I'm going to copy this launch file and start it up over here. And if I click enter and we wait a bit, we'll see a program open up called Gazebo. There we go. And this launch file does a couple different things. It starts up this virtual environment. It spawns in our robot as well. And what I'm going to do is I'm going to make this a little bit smaller too and put it in the corner over here and resize it a bit. Oh, that crashed. I'll have to start that again. This is also processor intensive, so sometimes you have to be careful. So I'm gonna, if this happened to you, then you'll have to like stop your launch file. So you can do that with Control C or just closing the terminal window. I'm gonna do the same command again here. Let's start that again. Okay. This time I'm gonna just put this over here. And as we can see, we have our little robot over here, our turtle bot, and we have a bunch of these obstacles and this virtual environment. And our next command is similar to that turtle sim teleop. We have our turtlebot 3 teleop launch file, and I'm going to be running that as well. So this will allow us to actually control our turtlebot. And what you'll see is I can use WASD and X to actually move around. And as you can see, as I'm tapping W, the robot's moving forward. When I stop, it still moves forward because we're setting like an absolute linear velocity. And if I click S or spacebar, it stops. I can do the same thing with the AS and D to actually turn the robot as well and keep driving it around. Okay, so let's see what topics we have here. So if I do this is not part of the demo, just actually taking a look at what topics are being published from all these nodes. So we have camera information, all these camera topics, a raw image file, command velocity. So that's actually to control the robot. And we have a bunch of stuff for Gazebo as well, and IMU, odometry data. So let's see. Oh, that's the camera image raw. That seems pretty cool. Let's see what happens if we do the same thing VRush did and just try to print that information and see if we can see an image. Okay, so we see a bunch of pixel values, but if I do Control C to stop that, we can see that this information is not really useful to us because we can't we can't make anything of this information. So that's why we have a program called ARBUS. So our next command will actually be running this program called ARBUS. And so I'm going to be pasting it into my third terminal window. And as we can see here, we have this program and we can see our robot similar to how we see it in Gazebo. But this time we see a bunch of these dots. This is laser scan information from a LiDAR. So there's actually a LiDAR at the top of this robot. If I zoom in, it's actually here. And on the left here, you'll see that we have a lot of options. If I close a bunch of them, it becomes more clear. Okay, so laser scan. If I just uncheck this, we can see that, okay, that's visualizing that laser. And pretty much what it's doing is everything that's being published on that scan topic is being visualized on here. So RViz knows a bunch of different message types and it knows what to expect. So that's why it knows how to visualize all this information. If I go to add, and I go to by topic, we can see, similar to how we did that ROS topic echo in the terminal, we can actually see a bunch of the topics here as well. And I could go to the same image raw topic that I couldn't really visualize here. And if I did the same thing, I can actually see like a virtual camera. So if I drive around, we can see that updating as well. And you can see that virtual camera is working there. That's pretty cool. And that's actually a depth camera. If I change the topic, I can get an RGB camera as well. So for SLAM, you need like a bunch of different sensors. You need like well, more information the better, but we have encoder data, we have the LiDAR data, we have the depth information and the camera information. We can use all this information to have a better idea of where we are and actually create a map of the world around us. So next thing we're going to do is actually run a SLAM algorithm called Gmapping. So this algorithm uses the LiDAR information and the odometry information from the encoders. So I can do the same thing to close this here. I can Control C onto this terminal window, or I can just close it. And I can open up another Ubuntu terminal window. And I can run this Gmapping. So this is going to open RViz again, but this time we're actually publishing to a map topic, and RViz is actually visualizing that map, as we can see here. Okay, so we can see we have black lines, which symbolize like walls or solid areas that we can't drive through, and then we have these white areas that are, which means they're drivable. And if I drive the robot around more and more, we can actually see the map start to fill out. And once you drive enough, then you have like a whole idea of what this place looks like, what this environment looks like, and you can then feed this map into other algorithms like for navigation, and that can be used to autonomously navigate the robot. Maybe you want the robot to go from here to the other side, but there could be, you know what the whole map looks like, but maybe one of these paths are blocked by something that wasn't on the map. The robot knows that from the LiDAR data. So, and it knows it can generate like the path of least distance around that. So let's see. Let's open up another Ubuntu terminal and let's follow Varash's last command here. So ROS run RTT graph, and let's actually visualize what this what the information looks like. Okay. So here it'll start to make more sense. we have this Turtlebot 3 teleop keyboard. That's this node over here, this terminal window. So we're sending, we can see that we're actually publishing to this command velocity topic, and then that's which is then publishing and sharing that information with Gazebo, which controls our robot, which all makes sense. Gazebo has some virtual sensors, and it has one of those sensors is for the scan, the LiDAR. So it's publishing that information to the scan topic. We also know that we have this Gmapping node, and it actually wants to subscribe to that information from that scan topic as part of its mapping process. So we can see that visualized here as well. And finally, we know that Gmapping spits out and publishes to this map topic. And that's actually what we're visualizing on ARBUS. So on the Mars Rover team, we're doing like we have like a bunch of these topics and nodes where we have a bunch of sensors, from encoders to GPS sensors to LiDAR to depth sensors, and we're using all this information to get a better idea of where we are and to map the world around us so we can complete some tasks autonomously. And yeah, that concludes the interactive portion. If you guys have any questions, feel free to ask them or unmute your mic.
So, hey there, Monish here. First of all, thank you guys. Great presentation. So I have a few questions in this. So first, I'd like to know which ROS version are you guys using for this demo?
Okay, so we're using ROS Melodic.
Okay, got it. All right. So the other one is, I'm a bit curious about how you install ROS on Windows. So is it like you've enabled WSL and then installed an Ubuntu OS on top of that? And on top of that, you installed ROS, or how's the procedure?
Yeah, so the way we actually documented our installation instructions. So we have this this link, and over here on my specific system, it's Windows 11, and I'm able to do technically you could do a lot of this in Windows 10, but you'd need some extra, like you have to do a lot of extra work to actually have this GUI stuff. But Windows 11 allowed us to actually run WSL with GUI and run GUI programs as well. So I'm on Windows 11, and then I went to PowerShell and I ran these commands, and then to install ROS, I had to set up the packages and the keys, and then I had to do the installation here. You can actually, if you have a Windows 11 machine, you can just follow these instructions exactly how it is, and you can have the exact same setup instructions as I have.
Okay, perfect. So, well, I actually tried this SLAM Gmapping once. So the problem that I faced was the environment was completely blank. So I was using a virtual machine where I installed ROS Node on Ubuntu 20.4, 20.04, yeah. So I was running this SLAM Gmapping where I found this complete environment was totally, blank. So I couldn't figure out like what was the reason for that. So I tried to change.
Did you have a robot, or did you?
I mean,
or was
everything.
It completely blank?
Yeah, everything was there. Actually, the robot, the environment, everything was there, but it was completely, let's say, transparent. It's like it blended with the environment. So I was not able to, get that in, especially in Gazebo. But when I tried to open RViz, it was okay. I was able to generate the map, but when I tried that in Gazebo, it was like completely blank. So do you know any reason for that?
I've never actually had that happen myself. Maybe if Farosh
Yeah,
We'll start with that.
what do you mean by transparent? Was all the models were like transparent in Gazebo?
Yeah, exactly. All the models, including the robot. So if you go to the view, and if you enable something called collisions, I mean, I can actually see the models.
Yep.
But if I just disable that, then it's like completely transparent. Yeah. Now, in this case, I can see the model as an orange hue, but yeah, if I disable that, it's like completely blended with the surroundings.
Interesting.
Okay.
So I did try. Sorry. Yeah.
If I was to guess, your virtual machine might have graphics driver issues that causes rendering problems, maybe. That could be a potential issue. I'm not sure how
Yeah.
your graphics is configured on the virtual machine. That's just my guess.
Yeah, even I think so. So I did change some of those settings of the virtual machine, but then again, the interesting thing that I noticed was the real-time factor. So here I can see it's 0.9596. Mine was like 0.4, 0.3. I think maybe that might be the issue there, right?
Yeah,
And
that's like that depends on your GPU and RAM. Yeah, because
Yeah. I think
that's fine.
especially because it
Real-time
was on a
factor is
virtual
fine.
machine. Yeah.
okay. All right. Awesome. So this is my final question. So when I'm trying to do SLAM, so we have a Raspberry Pi 4 with 4 gigs of RAM. So I'm just thinking like, can I just install Ubuntu on top of that, and Ubuntu first and then ROS on top of that, and we're using a RailSense camera, so we have a package for that. So will that be will the hardware be like, I don't know, compatible with that? What's your opinion on that?
You don't have to install Ubuntu. Yeah. Hashim, you can go ahead. You literally looked up into this. Yeah.
Yeah, I think that's the hardware is like fine, like the Raspberry Pi 4 and the RealSense cameras. I've been using the RealSense cameras with the Jetson Nano, and like that's been working fine for me. The way I have mine set up though is I have the I'd have like my computer like a Raspberry Pi actually running ROS. I'd have that have the camera plugged in, and I would actually SSH into that from my computer, and I would be running like a remote ROS. So I'd actually connect my actual computer like to that same network, and then you can actually you can set it up so that you can use RViz on your. It depends on if you're using Ubuntu on or WSO on your other computer though, but just for getting that information is, I think it's more than enough, especially for Gazebo might have some problems with the Raspberry Pi, but for RViz that should be fine.
Oh wait, so you have a robot, right? You don't need to run Gazebo if you have like a camera, your own camera, and a robot.
Yeah.
Yeah.
So yeah, I mean, I think SSH would be a better option because so for that, what do I have to install on the Pi? Can you say that again? If I want to remotely connect to Pi from my computer.
Yeah, so you can, if you want to just like control it, you can SSH into the Pi, or you can set up a remote ROS. It's like there's like tutorials for so if you just go to yeah, multiple machines, you'd have to follow these instructions, and like what you would do is you pretty much have to set up your ROS Master URI. You have to set that up on your personal computer, and you have to put the IP address of your Raspberry Pi. You might have to set like a static IP for your own computer and a static IP for the Pi, and then set these up. Otherwise, they'll change instead of how you'd write like 192.168 or whatever the IP is.
Yeah.
And yeah, so if you have to follow these instructions, and then you should be able to, pretty much what you'd be able to do is you could start launch files from your other computer. You could start nodes. You could like subscribe to topics from the other computer because it's all in one network. That's the beauty of ROS.
Okay. Yeah. Thank you.
Yeah. So you don't have to install Ubuntu. Raspbian has its own like ROS packages, so you can just I think Hashim like updated the install instructions on Raspberry Pi, how to install ROS on there. So you could just do that, and you can install ROS Melodic, and then you would be able to work. You don't have to install Ubuntu or anything. and that should be fine. And if you have questions, you can just message us on Teams or email us.
All right. Yeah, that works better. Thank you.
No problem.
Yeah, take note of our names just in case.
Yeah, sure.
Yeah, so if you guys have any like long questions, we have a GDSC Discord where you can join, and Hashim and Marash and a couple other MMR team members are there too, if you guys have any questions. Do you guys have any other questions right now at the moment? We'll be glad to answer them. Otherwise, we'll be wrapping up in a bit. All right, so thank you, Kylan. So Hashim, Marash, Ethan, do you guys have any plugs for MMRT? Anything going on in there that you would want to share? Maybe try to do recruitment pitch right now.
Sure, yeah. So first I want to say awesome presentation. Thank you, Hashim and Varosh. They really put a lot of effort into that, and I think it really came through, and hopefully the rest of you guys enjoyed it as much as I did. Yeah, so if you want to check out our website,
Also follow our Instagram.
yes, I'm gonna link the website in the Zoom chat here. It's mars@mac.ca, and you can kind of stay up to date on the different things that we're working on. Especially on the Instagram, we're shouting out different sponsors and different milestones we're hitting with the rover. Usually there's a team recruiting at any given point. Think we are running like rolling applications. So when a need kind of arises for a new member on a team, we're looking through different applications that people have submitted. So if you submit an application, we'll definitely take a look at it when an opening comes up. So anytime is a good time to apply. But yeah, once again, thank you all for coming out, and I hope you you took something good away from it.
If you didn't get time to try it out, you guys can try it out after this and contact us with questions if you have. Yeah, and we'll be glad to help you like try out the interactive demo. Yeah, at any other time.
So, right again, thank you for coming out. I know it's reading week now, so enjoy your reading week. We'll be hosting a few other events in the future, so make sure to check those out on the GDSC events page at some point. And yeah, that's it. I'll stop the recording now. We'll be posting this recording on YouTube, and it will all be updated on the event page again. And we might also send out an email for that. So yeah, if you guys missed something or have any questions, you can join the Discord again. If you scroll up just a bit, Kylan posted the link to it, and we'll be posting this on YouTube. So thank you for coming out.